All right, this is going to be part 2 of our Chapter 19 review. This is example 4. And of course, we know by now that the questions that are asked of us on quizzes and tests and ultimately the AP exam are going to be worded, very complicated, but really you just need to sift through it and find what is the really important information. So in this case, we are given a little bit of information. We know that the boiling point of this molecule is going to be 47.6 degrees Celsius. As soon as you see Celsius, you should automatically know that that's a red flag. We're also given that the enthalpy of vaporization is 27.49 kilojoules per mole. We want to know, what is the delta S when 24.1 grams of this stuff vaporizes at its boiling point? So, as we also know, a lot of chemistry is just, fighting through the trickery of our questions because we're always given the wrong units, right? Everything in chemistry is about knowing your units and pretty much just converting from unit to unit. So we can do a few different things. Like I said, when you're given a temperature in Celsius in a thermodynamics problem, you pretty much know that you're going to have to convert it. So step 1, we're going to convert our temperature. So we're given 47.6 degrees Celsius. We're going to add 273 Kelvin to get 320.6 Kelvin. Okay, so that's going to be our T. And actually, I'm getting a little bit ahead of myself. I want to remind you of this equation. We have our delta S is equal to our Q over our T. And remember, our Q, it's technically the Q in reverse. We're not going to worry about that detail. But our Q needs to ultimately be in joules. And our T has to be in Kelvin because we know that the units for delta S are going to be joules per Kelvin. Okay? All right, let me continue then. Our second step is going to be going from grams to moles, and I'll tell you why. We're given our enthalpy of vaporization as 27.49 kilojoules per mole. Ultimately, we want it to be joules. So the first step is going to be to get rid of these moles right here. Okay. So we're going to go. We have grams of this substance, and we want to get to moles. So we're going to do just our simple conversion that we've done a million times. When I add up the molecular weight of this, I get 186 grams. Mr. F, do you want to say hi?
No.
Okay. All right. So we can cancel our grams out, and when we do the math, we get 0.13 moles of this stuff. Now, like I said, we are... Okay. Step 3 is going to be that we're given our delta H, okay, our enthalpy of vaporization. Again, don't get confused by large words. You know what enthalpy is. They're just giving us a delta H. We're given 27.49 kilojoules per mole. And we know that in order to get rid of a unit on the bottom, we have to multiply by it. So when we do that, we are given 3.56 kilojoules. Remember, the moles went away because that was our point. Well, ultimately, we want to get this in joules, though. This is just a big game of manipulating our units and converting units. So, step 4 for this is going to be to get to joules. So we're given 3.56 kilojoules, and we want joules, so we're going to multiply by 1,000, and we get 3561.9, and that, again, is in joules. So now we are ready to plug it into our equation. Okay, so number 5 is going to be just to plug it in. So we have our delta S equals Q over T. This is now our Q. So we say our delta S equals 3561.9 joules over our temperature, which we found in step 1 to be 320.6 Kelvin, making our delta S equal to 11.1 joules per Kelvin. And we are done. Good luck studying.